Hello everyone. Today our class will be basically based on unit and measurement chapter. So whatever you are seeing right now, this is Jupiter taken by my camera. Okay. So why I'm studying, why I'm discussing about this chapter? Basically, I have given you one worksheet, and many of you have not done it. So I thought I should tell you and discuss some of the things of this chapter which are important. Now I'm not going into units because I think you can read little bit of units, but some of the things like measurements, uh, basically about length, I'm going to tell you little bit. So basically the thing that in the first chapter you are going to encounter, that is your measurement for length and like distance. But before going into that, I will also tell you something about solid angle. Now you know what is angle, right? So what is angle? So angle means inclination. So when we have two lines, so how the lines are aligned, like how much one line is inclined with another one, that is defined by angle, right? So this is called angle. But in case of 3D, so this is in 2D, two dimensional, we can get this. But whenever you talk about 3D, something different happens. Like I'm just telling you, let's say I have a torchlight. So when I have a torchlight, and I have some torchlight where I can control the exposure. So I can adjust the torchlight in such a manner that if I want to illuminate only a portion of only a portion of a place, I can do so. But if I want for a bigger exposure like this, then also let's say I can do the thing. So this is some kind of torch, let's say, where you can control the exposure. That means how much place you want to illuminate or exposed to my light beam. now now see, if you see these both cases, if you see these both things, the first beam and the second beam, that is this one, the bigger one, you can see that they both look like two conics, right? So how conics are looked like? So conics, I'm just drawing it roughly so that it doesn't take time. So that means this kind of conics. But in both of these conics, something you can see that in the next one, bigger one, the surface area is big, whereas this surface area is small. But you see, somewhere there is something like this. We can, like, if we take cross section, if we cut this place, okay, so we can get a small circle kinda like this, right? So as for 2D we say this is angle, as for 3D this thing is called a solid angle. Sorry, this thing is called a solid angle. Okay, now the solid angle, you can see it is basically your area, right? One kind of area, because I am taking a disc right here, right? So a solid angle is kind of area. Now let me tell a little bit about solid angle. There is one formula for solid angle. that is your D. So solid angle is notified as omega. Sorry, this symbol is called omega. Okay, so the formula for solid angle is d omega is your dA by r square. Okay, like this formula is similar to my what you say 2D angle. How? I'm just telling you. Let's say you have a 2D angle like this. So that will be your arc. So this is your theta. So if this is my theta, this is my radius r, and this is my ds. So I can always, so if this is my ds, I have to tell this d theta. Acha, this d means small. Okay, I was talking about differentiation. So this d means small. So ds means delta s, means a small portion of this length. Okay, d theta means a small angle, one small angle. So in this case also you can see that r d theta is ds. So my d theta will be ds by r. So this what you say formula is for 2D, but for 3D you can see instead of r there is r square. So in case of 3D we don't tell about angle, we tell about solid angle, and the formula for solid angle is dA by r square. What is A? Let's say you have a conical section like this, okay, and you have a surface area A, dA here. So this is your dA and this is your r. So the formula for solid angle will be this much. Okay. Now from this one thing we can prove. What we can prove? We can prove a very interesting thing. You know that the total area, surface area for a sphere is 4 pi r square. But how it is coming? If this dA, so one thing you can see that this dA is actually the surface which is exposed outside. So here if we create a solid angle, so this will be my area, right? So this will be my area. Now if I join the whole thing, okay, so you can see that my d r square d omega is my dA. So my total A will be r square summation of all d omega. Now one thing you have to know, but it will come later on anyway. So right now you just know as a fact the total angle, the total solid angle for one point, okay, is 4 pi. Like if you add all the small solid angles like this angle, okay, to the whole, like throughout the sphere, you will get 4 pi. So this will come later on in mathematics or in physics, so you will know it later on. So for now you just learn as fact, okay, this whole solid angle for one point is 4 pi. Like we know that angle for a whole, like in 2D, two-dimensional, the total angle is 360 or 2 pi. We know that, right? So like that only the solid angle for the whole three-dimensional aspect is 4 pi. So instead of this sigma d omega, we can write 4 pi. So ultimately we can get the area of a whole sphere is 4 pi r square. So this is all about your solid angle, okay, and like we can tell many things about it also, like if we have to define what is solid angle, please define solid angle. So how to define, like how to give the definition? So there is a very nice way of giving definition here. You can see the formula here, d omega is dA by r square. Now if r equal to 1, that means the distance I have taken 1, so I can found d omega is my dA. So what is solid angle? So solid angle is the area of exposure. So solid angle is the area of exposure if I take radius equal to 1. So solid angle for like conical section will be the area of exposure if I take the radius to be 1. Now what is the unit of solid angle? Steradian. Okay, now you know that in 2-dimensional angle is radian, right? So this is called steradian. So radian, with that this is added to steradian. So how to define one steradian? So one steradian is the surface area of the surface area of exposed part, okay, of a conic section or the base of the conic section when the radius or this distance is taken as 1. So in book you will get a nice definition. Okay, so you can see from the book how to define this radian. Fine. Achha. And like steradian and solid angle. Now coming to the most important thing, the next topic, that is our parallax, and this I have to teach you like nicely, and you have to also concentrate a little bit. This is called parallax. What is your parallax and like what I will do with this? Now parallax is a method. Okay, so this is a method to find large distances. Now this we will not only use in our theoretical aspects, but later on in class 12 you will have one practical on optics where we are going to use this technique, parallax method. Now so this is linked with basically distances. Now what is it? Let me give you one example. Let's say I have one boy here and his name is A. I have another boy here whose name is B. I have another boy here whose name is C. Now I am standing, say, in this position. So my eye will be here. But when I will see behind A there is C, right? Achha, one more thing I have to tell you, that B and C, they both are in same line, okay, same like distance from this plane, from the plane of my eyesight. Like this is the plane. I am not going upside, I am not going down, I am in the plane. I can move my eye in this plane, okay, and B and C are in that plane, okay. Now when I see from this position, let's say position number D, so I will see that behind A, C is standing. But when I will see from this position, I will see that behind A, B is standing, right? So let's say this is E position. So when I am changing my position of observation, I can see that the the back side of this A is changing, right? But if this A I bring here, Then irrespective of my position, that means in this case A is not here. So irrespective of my position, I will see that this A is in the, like A, B and C are in the same line, like the background will be same. So why this is happening? So this is happening basically because there at first when A was here, there was a distance, there was a separation between the plane of A and the plane of B and C. So this is the separation, right? Because of this separation, we can tell that my background is different, right? You can do the same exercise with your finger. How? You take your finger little bit near to your nose, approximately 30 to 20 centimeter apart from your nose. Now close your one eye and see what you can see behind your finger. Now close your left eye and see what you can see behind your finger. You can clearly observe that in both cases the background is changing, right? Now take your two finger, one finger farther and one finger closer. Now do the same experiment, okay, same exercise. Still you can see that if you close your eye and if you open your left eye, what will be the background? If you open your right eye, the background will be changing. But slowly if you move your two fingers in a same line, that means at the same distance from each other, you will see that irrespective of your eyes, you can see the both fingers all together. So again you can do that. You bring your one finger closer, you can see that the position of your two fingers are changing when you are opening and closing your eyes. That means when there is some separation between you and what you are seeing and the background, okay, so there will be some parallax effect. So this is a parallax effect. So I will attach one more video where with animation it is very clearly described and explained what is parallax effect. Okay, now what we are going to do with this parallax effect, we are going to find the distance of planetary objects. Okay, why? Like we know that they are far away from us, right? Let's say we have sun here. So I'm making a sun right here. Okay, so this is my sun, and let's say my earth orbit is this one. Okay, and there at the far distant there is a small star. So when earth is there, and when earth is here, two situations we will compare with each other. Now when earth is upside, earth will see, means we will observe the star we will observe one point of a star. Okay, and when earth is here, we will observe it again. Okay, so you can see that in both cases my angle of subtension is different. With respect to what? With respect to our own position. Fine. So this angle is called parallax angle. So this is called parallax angle. Okay, this distance is called basis. Now let's say this distance is our b. Okay, this is our d, the what to say, the basically the distance between that star and our planet. Okay, now we know that for very small, if this theta is very small, so when it will be small? For larger distance. So more this star will go farther and farther, so more this star will go farther and farther, these things will be narrower, right? And my angle will be smaller and smaller and smaller, right? Okay, so for further objects we can tell that theta is very small. So when theta is small, this b will act as arc length. So b will act as arc length. So you know, for arc, if radius is r and angle is theta, so the arc length will be r theta. We will apply the same. So b will be my d theta, right? So my d will be b by theta. So the distance for one star can be easily found with this kind of parallax method. So what we are doing exactly, actually we are measuring the angle at this position, then we are measuring the angle at this position, we are comparing these two angles to find out this theta. We also know the value of b because we can find it very easily. We know the orbit length of our orbit. Okay, so basically the distance between you know that later on I will discuss again, the distance, average distance between sun and our earth is called as 1 astronomical unit, right? So and the value is known to us. So with this method we can find out the distance of that planetary object or star. Now we can not only find the distance but also we can find the diameter. How to find the diameter? Let's say the star is that big. Okay, the star is that big and this is our earth. So earth I am drawing small and blue. Now you are standing at this point. This is the point of observation, let's say. So from here, first what I will do, at the same time I will see this upper corner or the extreme part of the star, and then again I will look at the minimum point of that star. Now we already know the distance, big D, right? So this is my big D in this case, which is almost will be same, and this is my angular, what you say, x, let's say this is my angular, like sorry, this is my diameter. Okay, diameter of that respective star. This is my angle of subtension. That means if I say this is alpha, so this alpha will be my what do you say, parallax angle, right? So my alpha is parallax angle. So again I can use the same method, x equal to alpha into d. Now see, already you know what is your d, so easily you can find out what will be the radius. And this alpha can be called as angular size or the angular diameter. So from the first method we are going to find out the distance of that star, and from the second method we are going to find out the diameter of the star. So for the first method I have to wait a longer time, at least 6 months, so that from one point of the orbit I can come to the another point, like opposite corner of that orbit, and the next one from like earth only, irrespective of my like time and everything. At the same time I can take the observation and I can find out the angular diameter or the diameter, physical diameter of that star. Now there are some examples in NCERT also you will find, so try to do okay some of the examples. Okay, now something we have to discuss, that is the measurements of length. So I will talk about the like this has been done for how to calculate the bigger length, like distance of planetary objects. Now how to find the smaller one? So you know the how small we can go. We can go to cell, we can go to molecules, we can go to atom. Right now we can still like take picture of atom. Okay, now what we are going to use? So we use some kind of say this is called tunneling microscope. This is called electron tunneling microscope. Okay, so this actually uses some of the quantum effects that you will study later on. Okay, and one more thing is there, it is called electron microscope. So this is basically used for like used for taking the picture of molecules. Okay, even some of the viruses, some of the what you say particles. Okay, so these things basically works on the principle of diffraction. That also you will learn in class 12, what is diffraction, how electron microscope works. So basically using this kind of tools we can find out many small objects, what you say dimensions. Now we know that with normal microscope we use only photons, and with photons we can only measure the like cell and some kind of things. But if we want to measure smaller things, okay, then we have to use these two things. Acha, now talking about the range of our distance, like length. Okay, so range of length, if we talk, so we have in the bigger side, so let me take a separation. Okay, then in the bigger side we have big units, like your 1 light year. So what is your 1 light year? 1 light year is the length that light travels in 1 year. We know that what is the speed of light? Almost 2.998 10 to the power 8 meter. So in 1 second per second. So in 1 second light can go up to almost 3 into 10 to the power 8 meter, and that's huge. So in 1 second light go that much. So in 1 year how much light will go, you can calculate, and that is extremely big. I'm just writing you the result. Okay, and the result is very big. What is the result? The result is your 9.46 10 to the power 15 meter. So you can understand how big is the dimension, like how big is the order. Now we also use something which I already mentioned, astronomical unit. So this is what astronomical unit is: the distance, the average your distance between sun and earth. Okay, why I'm telling average? Because you know the orbit of the sun and earth is elliptical, it's not circle, and sun is in the one of the epicenter of that ellipse, and our earth moves around it. So always the distance between them changes, so we have to take the average. So the average distance between sun and earth is 1 astronomical unit, and that is equal to 1.496 into 10 to the power 11 meter. One more thing we use, that is called parsec, but that is little bit complicated. So let me tell you what is 1 parsec. So 1 parsec is actually, the value of it I'm just writing, but 3.08 into 10 to the power 16 meter. So it is bigger, right? It's very big. But what is it? You have already learned about parallax, right? So this image I have taken from Wikipedia. Okay, so what is 1 parsec? See, we know that when we see a star, this angle we call as parallax angle, right? So the distance for which, so this is that distance, okay, the distance for which this angle will be 1 arc second. Now you will say, sir, second, this is the time, this is the unit of time. Now see, we can further split 1 degree. So if we have 1 degree, and if we have to go lesser than that, so how to go? So we can split 1 degree into 60 part. So one part will be 1 minute. Actually it is called 1 arc minute. So this is called 1 arc minute. But if we want to go farther smaller, then we can again divide or split the 1 arc minute into 60 part. Then one part of it we can tell 1 arc second. So one thing I will tell you that so first let me summarize. So 1 degree is 60 second, 1 degree is 60 minute, and 1 minute is 60 second. Now one thing you see, I told you already that when this star will go farther, this angle theta will decrease, because this triangle will become sharper and sharper and sharper. So for very far away, like stars, okay, the farthest stars, we can say that this angle P will be so small that it will become like 1 arc second. So that distance for which that parallax angle will become 1 arc second is called 1 parsec. Now you understand, like, so how to define 1 parsec? 1 parsec is the distance of a star or an object for which the angle subtended or the parallax angle will be 1 arc second. Okay, so this is your 1 parsec, and this is little bit like important. Okay, so you have to learn the definition, sometime it may come. Okay, so the next one is your smaller unit. Now we have talked about 10 to the power 15, 10 to the power 11, 10 to the power 16. Now let us talk about the smaller. So we know that smaller angle means smaller like order will be like millimeter. Millimeter means 10 to the power minus 3 meter. What happened? just a minute. So 10 to the power minus 3 meter. So 1 millimeter is your 10 to the power minus 3 meter. Smaller is there, micrometer, that is 10 to the power minus 6 meter. Nano, 10 to the power minus 9 meter. So this is called nanometer. Okay, what it is called? Nano. That nano ka, you know. So that's why it's called nano, because it's small. There are nanoscience, nanotechnology, so many nano things are there. Okay, then we have picometer, 10 to the power minus 12 meter. Then we have Fermi, 10 to the power minus 15 meter. But one more interesting things we have skipped here, and that is used in a huge way, that is angstrom, 10 to the power minus 10 meter. So basically these things are important: Fermi, angstrom, nano, micro. These things are mainly very much important. So coming to like viruses, they are in kind of like micro to nano, like generally they are kind of micro to nano. Okay, talking about nano, we have nanotechnology like chip fabrication. You know, there are processors, and nowadays some kind of like processors are generally was being done by millimeter range, but now they are trying to do in nanometer range. Okay, so why nano? Because in a small place we can set up more like chipsets in that case. So nowadays nanotechnology is that's why important. Talking about like atomic size. Okay, so atomic size is nearly, not exactly till this much, but lesser than this. Pico, nearly, it's not exactly, I'm telling you. Okay, Fermi means the size of nucleus. You know what is nucleus? The center, the positive charge center of an atom, where your proton and neutrons are there, bind together. So that size is nearly 10 to the power minus 15. What is angstrom? Angstrom is the how to say, angstrom is the like distance between lattice. Now we will say, so what is lattice again comes here. So lattice means a crystal. You know what is crystal? Some particle, some kind of what you say, material is there. Those are very periodic in nature, like your quartz crystal, your NaCl, that is table salt, like your salt, your diamond. So they are called crystals, because crystalline materials, because their atoms and molecules are very like arranged in a very periodical nature. So this distance is roughly about angstrom, means 10 to the power minus 10. And we also get wavelength of light in this order, that is angstrom. Okay, like x-ray radiation we get in this order, angstrom. So that's why it is important. So already we know about these things like the range. Key for the bigger things we can use this light year astronomical unit, that is the average radius, average distance between earth and sun, and your parsec, that is like the distance for which angle or the parallax angle subtended is 1 arc second. Okay, so these are the things you have to know. Now in your NCERT book I have seen that there is estimation of a very small distance size molecule, and there an example like what I can see is oleic acid is given. Now see, this is not a general like method, so this we can do only for oleic acid, but this is not a general method. But when to like what you say, measure very small things, we take help from different kind of methods. Okay, otherwise we can see from these two machines. Okay, we can take help of these two equipments I told you before only. So basically this is it. And if you want me to explain this oleic acid thing, just tell me. Okay, I will teach you this thing also. And it's very like easy thing. Okay, uh, the next thing in your worksheet also I have given, I think, and in example also it is there. If the size of nucleus is scaled up to the tip of sharp pin and blah blah, this question may seem very like, what is this? But actually what is it is like, what it is meaning to tell you ki how to compare. Like if you have one atom and you have nucleus in it, how to compare? Like, see, I'm just telling you, the size of needle, like sharp pin, this size is nearly about 10 to the power minus 5 to 10 to the power minus 4. So this is size is given, okay, in the book. We know that the size of nucleus is in Fermi order, that means 10 to the power minus 15 meter almost. But the size of your atom is 10,000 times less than that. So it will be minus 11 meter almost. So you can see the ratio here, almost 10,000, right? So see, so in that case, how to compare like this scenario and that scenario? So in the like book it is told that if we have to create this situation with my pin, what I have to do, I have to take meter 1 meter distant. So this is my 1 meter distant, and now if I put that pin here, pin tip here, so this point, basically this individual point will be nucleus, and this whole scale will be my atomic structure. So this is just done to like understand ki what is the like comparison of the sizes between your nucleus and your atomic structure. So nucleus is 10,000 times smaller than your atomic structure. So there are more things like measurement of mass, and you know that measurement of mass is done in the unit of U, right? That is 1 U. What is your 1 U? 1 U is the 1/12th of the mass of an atom of carbon. So there is some mass, okay, of carbon. Now you know that carbon is 12 6. So there are 6 protons and 12 proton plus neutron, right? Neutron. So 1 U is 1/12th mass. Like see, if you tell me what is the, you know that almost the mass of proton and mass of neutron is same, but they are not exactly same. It's almost same. So if they are almost same, so for 12 of them we can tell that 12 into mass of proton, sorry, what I am doing, acha, so 12 into mass of proton we can calculate, because the mass of proton and the mass of neutron is almost same. So if we calculate this and then again divide by 1/12 of it, we will get the mass of one proton, that is 1.66 into 10 to the power minus 27 kg. So ultimately 1 U is 1.66 10 to the power minus 27 kg. That is almost nearly the mass of proton. Okay, so this is for the smaller quantity, and for the bigger quantity we know that for planetary systems we can like express as ton. Okay, and like we can write like 10 to the power something like 14, 10 to the power 20, like this. Okay, so we can tell like this. Now range of mass you can read by your own self. Okay, so in the book also I will tell you to just I will suggest you just to see there is some table called range and order of length, so you can get a rough idea of proton size to a distance of like the boundary of universe that can be seen. So you can roughly get an idea like what is the range of physics to work, like from studying from very quantum effects like the inside structure of the nucleus to the cosmology, that is the finding out how much we can see in the universe, what can be the diameter and the end point of our universe. So these all things we can do in our calculations via in physics. Measurement of time you can see, and it's quite easy. And the next thing is called your uncertainty and errors. Uncertainty and errors. So this thing in the next class I will tell you and explain you, and also I will provide one very nice manual or tutorial kind of notes. You can see that note and easily you can do most of the problems. And as uncertainty and errors problems are very easy only, so you can do it. Okay, whatever thing is possible I will teach you as far as I can, whatever is there. And this is it for the class. So today I'll advise you to kindly see Parallax one more time. Okay, and please see the attached video also what I'm sending right now. And please submit your works in the group, so that because I am taking the note who is submitting, who is not. I am very happy with those who are submitting. Plus but I just want you to try. It's not that you have to do everything, you have to copy and give. You just try. If you don't understand, please ask me, I will explain. And sorry for this kind of class, because it's very difficult to take. But if you guys are insisting and everyone is available through online, and if you don't understand anything in some matter, then we can also do video calling. Okay, but that is only possible if everybody is active. So for today this is the thing, and try to solve that worksheet. Okay, so bye bye, see ya in the next class.